Hello everyone, it's Nathan. This is another video response to John Saunders over at NYC CNC, and he's inquiring about some of the management of parameters inside of Fusion 360. So I'm going to go ahead and start creating the part that he made and show you some of the things that I would do a little bit differently to enable more management of the part and scalability. Say we wanted to create this part and it was a 1-inch part. There are ways inside of Fusion to be able to scale that from a 1-inch part to a 2-inch part to a 2.57-inch part, however you want to go with that. So inside of this, one of the first things I did was I started by creating a center point rectangle. One of the reasons I do this is by creating a center point rectangle, it is based around the origin instead of another feature outside of space. So when we scale this part, any symmetries that we have in mirroring or other components can be done off the X and Y axes, and it can create a lot less of a headache later on when you're trying to scale multiple parts, particularly in an assembly. And this way you're not worrying about relocating or remanaging dimensions in the sketch that are redundant. So let's go ahead here and start creating some dimensions. Now this first dimension is going to be what a lot of the rest of the sketch is dimensioned off of, and John Saunders did a great job of explaining this. The second dimension is going to be a function. So we're going to take that first dimension, which is D1, and we're going to multiply it by 1.5 because we know that is the ratio that a 1, 2, 3 block uses. And now if you notice, if I click up here and create this as 1, it's scaled. Because of the function here, I didn't have to go in and edit 2 dimensions. I was able to edit just 1 dimension right here. And because I only had the center point rectangle versus a rectangle in the upper right hand quadrant, I'm able to keep everything centered on the origin. Now the next effect that he utilized was Microsoft Excel, and he took and created some programs inside of Excel to mathematically figure out where the rest of these holes are placed. And I just want to show that a lot of those functions can be done inside of Fusion 360. Systems like Inventor or Creo or a number of the bigger drafting softwares, parametric modeling softwares, are capable of actually utilizing Microsoft Excel files. However, inside of Fusion 360, that's not something that they focused on. So I want to show how you can create those functions inside of Fusion 360, so you wouldn't have to be going back and forth changing all those dimensions, and this will become a truly scalable model right inside of it from a couple of dimensions. So this right here, we're going to dimension, and we are going to utilize another formula. And I'll explain this here in a moment if you bear with me. Now, if you've seen John Saunders' video, this is the same number he got. This is just abbreviating it a little bit more. I don't have my spacing or rounding out as far as he does, but this will round out to 0.40625 is rounding up to 0.406. But you can see that we got the exact same dimension. Now, if I hover over this, it's going to show me the formula. And actually, let me click on this so I can explain it to you. This is the formula that we used. Now, D1 is our first dimension, and that's the 2 inches. And the reason we're trying to do this all inside of Fusion 360 is so that we can literally take this D1, edit only it, and everything will repopulate in the dimension when we want to scale this to a 246 block instead of a 123 block. Now, D1, this is the 2 inches, so it's the what we'll call the width of the part, and the width of the part minus D3, which is our whole dimension, times 3, because there's going to be 3 of them across the width of the part. So D3 times 3, all of this, D1 minus all the holes. What that's going to leave and show us is the remaining space that's going to be between this hole and the next hole and the next hole and the edges. And by doing this, we now have the math for the spacing in between each of our parts. And by dividing that by 4 now, all of that space divided by 4 is just the nature of having 3 holes in a square. There are 3 holes here. Let me just draw them out for you. If we have 3 holes in a line, we're also going to have 4 spaces that we have to make up for. So when we create this pattern, we want to know the math between exactly how much space is between this wall and this hole, and this hole and this hole. And as you can see, by adding in the change in dimensions from D1 to D2, and changing the number of holes that we're going to be having to 5, and thus the number of spaces to 6, we now have 2 functions instead of just numbers. So when we go in and change this dimension, everything scales. As you can see, this is no longer 0.375 inches from the top. It's scaled as a basis of that function. So we'll go back to 2 and we'll continue with the project. So we'll stop this sketch, modify, create extrude. And the first dimension we started with was D1. Now all dimensions names are case sensitive, as John Saunders pointed out. So to work with D1, you need to go with D1 and then divide that by 2. So once again, we're focusing on keeping everything as a function so that when we scale those numbers, everything scales with it. And now we've got the beginning of a 1, 2, 3 block. Now we're going to create a pattern of the hole that we were left with when we extruded it. Pattern, rectangular pattern, select the feature, select the directions and the X and Y axes, and we're going to do spacing. So previously when we were doing the spacing between the wall and the circle, our equation, which we're going to be using again, looked like this. And this D3 divided by 2 here is the radius of the circle, because we had a flat edge going up to the radius. Now we're going again between the center points of the circle, which are right here and here, so we need to be adding in the diameter instead of the radius. So just by taking out that divided by 2, you can see the spacing is nice and equal now, and we're filling the part. Now on the bottom here, we've got 5 holes that we put in, and we're going to use the same equation we used for the Y separation right up here. And as you can see, we've got a fully spread out holes. They all look to be symmetrical and equal. Hit OK, and there are holes. Now coming onto the side here, sketch, and I'm going to project geometry. So I'm going to go look at the origin over here. My apologies, I happen to have moved this. And I'm going to project the x-axis, and I'm going to project the y-axis. And make these construction lines. And I'm going to create a circle. And instead of creating a specific dimension on a circle, I'm simply going to enter in D3. So these are going to imitate every time the exact dimension of that one circle. Once again, in parametric modeling, it's all about creating as few parent dimensions as possible, those first couple dimensions that everything else references. That allows each of these pieces to be scalable. Now we'll stop sketch, extrude, and we're going the wrong way there. But instead of using a dimension, once again, D2, negative D2. Usually the cut would reverse it for us, but in this case we're going to have to manually do it. Hit OK, and we've cut all the way through the part. Now once again we're going to create a pattern. Select the feature. In this case, we're going to select the feature from down here to make sure that we're getting the entire cut versus just the beginning cut. If you notice, when I selected initially the pattern feature, I was only able to select these faces, and we didn't select the rest of the faces that go all the way through the part. So oftentimes, unless you want to only be patterning a portion of what you're originally intending, go down here to the history, select the entire extrusion. Directions, this pattern, now we only have one hole on this edge, so that pattern only has one direction. And we're looking again, use the X. Instead of doing one direction, do symmetric. So it's going to go in only one direction, one axis. However, it's going to go both directions on the axis, the positive direction as well as the negative direction. And those look to be symmetrical. Hit OK. And we have them in place. Creating another sketch. This face. Once again, we're going to project the X and Y, Z axes in this case. Oh. Place in a center point circle. D3, this dimension of our circle, will always stay the same. Finish sketch. Extrude that. I'm going to go negative D1. That's going to put us all the way through to the outer edge. OK. Create a pattern. Directions, the Z-axis, and again we're going to go spacing and symmetric. There's going to be 5 holes this time, and we're going to use the same dimension that we used, or same equation that we utilized previously. There we are. Hit enter. We've got our 1, 2, 3 block. And there's a number of things we can do here, add threading and chamfers. I'll go ahead and add a chamfer onto the edges here. And any feature that you create within this model can be referenced to other geometry. So this distance even, we're going to create as a function of D1. So D1, which we happen to know is 2 inches, divided by 16. 4. There we are. And now we have our 1, 2, 3 block. And the biggest key here is going to come up in managing features. So under the create or modify option here, we can change parameters. Now you're only going to see this option if you have a dimension placed. So if you're doing something with freeform modeling and you haven't put any dimensions in place, this change parameters option will not populate. So if we go into something that I have here, and this is all done in freeform, go into modify, nothing here. So if you don't see that, make sure you've created a dimension already. So down here into modify, change parameters, and this is going to look a little bit complicated, but I promise it's not. If we go down here and open up all these submenus, what we're literally seeing is every single parameter or dimension that we've created in the entire history of this project. So if we expand this open, grow it open, the reason we've created all of these different equations is so that we don't have to worry about every single one of them. The only 2 that we care about is this linear dimension, which is D1. We see the name here, and we see the expression, which is 2 inches. That's the first dimension that everything else is featured off of. D3 is the other dimension. That's the dimension of the hole. Now, one of the biggest powers that we have inside of the parameters management is creating a name. We'll simply name this hole diameter. I apologize. You have to keep it in a single word. And here we're going to create, what do we want to call this? Width. Now remember, Parameter names are case sensitive, so you're going to have to type this exactly letter for letter the way that you typed it. But we can go in here now, and if we were to hit OK, let's save this file. And I'm going to call it a base because it's something that I use to describe something that I can modify. So we're going to exit out of this, our 123 block base. Now coming from absolutely nothing here, we're not going to open up a sketch, we're not going to open up anything. The only thing we're going to pull up is change parameters. I want to scale this. Let's go ahead and make this a 246 block. Change this to 4 inches, and change this hole dimension to 5/8. Hit OK. We haven't done a single thing inside of the sketch, and let's go ahead and do an inspection. Inspect from here to here, and you'll notice the distance between these two faces is 4 inches now. Let's go ahead and inspect from here to here. Oh, I'm sorry, we have to inspect again. Here to here. Look at distance 6 inches. All of these holes are symmetrical. We don't have to worry about changing any dimension inside of these sketches. We don't have to recreate a pattern. Absolutely nothing. Everything is done for us. And one of the biggest things in this is, if we notice, this entire part, if you see the axes that are going through these holes into the origin, this is based on the origin, and it can expand and contract as we want it to. Let's go ahead and modify this. It doesn't have to be a whole number. Let's do 1.5 here. Something that doesn't actually exist, but I'm going to say maybe that has to be a 1/4 inch. Voila. Let's take a look at an inspection. Measure this to the distance between these two faces, and 1.5 inches. So this is a really powerful aspect of parametric modeling, and most of the time you're not going to necessarily have to utilize this, but say for example you have to create something that's a pin, and you're going to be using this pin in a bunch of different assemblies. You're going to be using this pin in a bunch of different projects that may be smaller or larger, and you always want to have that similar degree of chamfer or for example a degree of slope to it in a mold or something like that. All you have to do now is create one of them, go into your part file, modify the parameters, change its hole diameter or a screw's diameter, and then exit out and save it as a new part file. Instead of having the redundancy of recreating and recreating and recreating parts, the core of parametric modeling is the fact that you're able to create something with reference geometry and reference dimensions. And every single one of these pieces is going to be scalable and modelable without having to go in and recreate a sketch or create a part from scratch. So hopefully this is helpful. I know it's a little bit long-winded, but John particularly, hopefully you get a little bit of information off of this. It's great to see you getting to some more of the advanced features of parametric modeling. It's incredible to see it fleshed out inside of Fusion 360. Thanks.